Hello students, welcome to Nilachal Polytechnic. Myself Amarendra Mishra belongs to Mechanical Engineering Department. My subject is Fluid Mechanics. Here in this video, we are going to study about the properties of fluid, that is first chapter of the subject. These are the contents related to chapter number 1. We will study about the definition of fluid mechanics, definition of fluid and its properties like mass density, weight density, specific volume, specific gravity, viscosity, kinematic viscosity, concept of surface tension and capillary phenomena. Let's come to the introduction part of the subject. There is a idea comes in your mind that why we are going to study about this subject. How to define the subject? Fluid mechanics, it is the subject of mechanical engineering department which deals with the study of behavior of fluid. The fluid may be at rest condition or may be in motion, and their application in mechanical fields. Based upon the different condition of the fluid, we are having fluid statics, fluid kinematics and fluid dynamics. Let's come to fluid statics. The fluid statics deals with the rest condition of the fluid. We may take the example of the water stored in a well, the water in a pond. Like in the diagram, we have seen there is a glass tube in which water is present and there is no movement of water. Similarly, in this diagram, the water is at rest condition, there is no movement, there is no flow of water takes place. Next, go for fluid kinematics. There are two types of studies to observe the motion of the fluid. If you are considering the forces which are causing the motion of the fluid, then that is known as the fluid dynamics. But while we are considering the fluid kinematics, here we are only observing the motion of the fluid. We are not knowing that what are the external forces are causing the motion of the liquid. As shown in the figure, we are having the waterfall where the water is in motion from top to the ground surface. Similarly, here a person is riding the bicycle, while this time the atmospheric air is in contact with the motion of the bike cycle. Now let's come to fluid dynamics. Fluid dynamics means we have to go for the knowing or observing what are the forces are causing the motion of the fluid. What is the main forces due to which the water may be moves from one point to another point. Like in the figure, we have seen that there is a curved surface, and in this type we are seeing that all the liquids are flowing from one point to another point. We are going to see that the velocity may be decrease or increase. So that is the main function, that there is a force is applied upon which, due to that there is a motion takes place. Similarly, there is a venturimeter. We have seen that due to the movement of the water inside the venturimeter, there is a level of mercury maybe changes across the U tube. This is known as your fluid dynamics. Let's come to the definition of fluid. Fluid may be defined as a substance which can flow. Also, it can be also defined as if you are pouring the substance on the floor surface, then it will be flow away. Like in the figure, we have seen that there is a tap. From the tap, there is a substance. It is moving away from the tap, and this is known as your liquid. The fluid is in form of liquid and gases. Like I have taken a cup of coffee, where I am going to stirring the coffee. That is, there is a movement of the liquid takes place inside the cup. Fluid is in the form of liquid and gas. It has no definite volume, and it takes the volume of that container in which it is kept. Liquids as example as petrol, diesel, oil, these are the best example of liquid. Gases means that may be nitrogen gas, oxygen gas, carbon dioxide gas, LPG, CNG. These are the example of gas. After finding out that the definition of fluid, let's comes to the properties of the fluid. To identify different kind of liquids, where we have to know their identical behaviors. By studying the identical behavior of each liquid, we can make that use of each fluids in any type of application. These are the following properties of fluid. We have to study: mass density, weight density, specific volume, specific gravity, viscosity, kinematic viscosity, surface tension, capillary phenomenon, etc. Let's come to the description of the property like density and specific weight. Let us consider there is a container inside which we are going to keep the liquid inside it. Now we are going to measure the density of the liquid. For mathematical expression view, we are going to see that density is defined as mass per unit volume of the fluid. Also we can take that measure of quantity of fluid contained in a volume of container. We know that while we are keeping the liquid inside the container, it takes the volume of the container, and it is denoted by symbol rho. Rho is equal to mass by volume. In SI unit, we are going to say kg per meter cube, and in CJ system, we are going to say gram per centimeter cube. For water, it is 1000 kg per meter cube. Let's come to second properties of the fluid, that is specific weight, or that is known as your weight density. Weight density means that is the weight per unit volume of the fluid. We know that weight is equal to W and V is equal to volume of fluid. Mathematically we can written as W, small w is equal to capital W by V, where capital W is the weight of the fluid and V is your volume of fluid. We know that weight is a force and it is in unit Newton, and for volume it is meter cube. So Newton per meter cube and Dine per centimeter cube, this is the unit of specific weight. It is denoted by symbol small w. Then we have to find out what is the relation between density and specific weight. We have seen that density and specific weight, as specific weight we have W by V. W is equal to mass into acceleration divided by V. Mass by volume, we know that rho. So rho into G is equal to specific weight. While we are solving problem related to this, we have to remember the relation between rho and specific weight. Let's come to specific volume. It is the reciprocal of the density, mass density. The specific volume is given by the formula volume by mass, that is V by m, and also m by V is known as rho, so 1 by rho is equal to specific volume. Now comes to the unit of specific volume. For unit point of view, volume is equal to meter cube and unit mass is in kg. So in MK system it is meter cube per kg, CJ system it is centimeter cube per kg. If you are finding the relationship between specific volume and density, that is specific volume is equal to 1 by density of the liquid. Thank you.